Okay, we can start now. Did you guys manage to resolve this one again? Who did solve this? I asked you to solve it, right? I think we have discussed already the example 7, right? And we need to find the voltage. Okay. Excuse me, guys. So we have three integrations, right? First integration based on phi, then we have second integration is based on phi, and the third integration is based on z. I believe all of you know how to do the integrations part. Okay. You can see this one is easy to do it, right? Which we have to change the variables. So we have for b squares, we have 5 squares divided by 2, negative 3 squares divided by 2, then we have 8, then we have 2.269, negative 1.745, we have 0.524, then we have 4.5, negative 3, then of course we will get 1.5. You multiply each others, you will get the volume is equal to 6.288. Then if you want to find the surface, we have to use these equations, okay, which I already described to you, right? Which we have the total area, okay, of the surface. We have two integrations, we have two integrations as well. So we have for both, we have one for top and one for down. Of course, we have to put 2. Okay, then we have the second value, which we have it 2 integrations as well, 3 d phi dz. Then of course we will have it for the second one, which is integration 3 to 4.5, 1.7, 5 dc. First we have to take it for 3. The second one will be for 5. I already explained it last week, I think last class. Then of course we have the same, we have 2 curve area, right? Of course, so we will repeat it 2 times. So of course then we will have 2 here. This is quite long. I don't know, it's not that difficult one. If you want to see the calculation part, I have put it here. Okay, I think I have a small mistake here. Negative, positive. So you have, these are descriptions one by one. Okay, 2 plus 1. So we have it for both. Integrations for 1, we have b squared divided by 2. So we have 5 to 3. Then we have for phi, this part, okay. Then the second one, we have to multiplying based on phi and based on integrations based on phi and based on z. And also here. Okay, then the last one are and here. Okay, you do all integrations part. So you do this integration part, you have to see the range of integrations. Range of integrations is from where to where, right? Then we have to find the last value, which equal to 20.7. So I believe all of you know how to do these type of integrations, right? Please guys, if you have problems even in mathematics, I can help you, no problem. Okay, so let's move to this example. So this example is easy example. We have to find the area of cylindrical surface while we have r is equal to 5, okay, and we have the angle is in between 30 and 60, and z are from 0 to 3. So the integrations part are this one, r d phi dz. Okay, so we have integrations, okay, r d phi dz. Okay, the first for the angle, if you want to have it for angles, then from angles you have from 30 to 60. Then for z is already written here to you, 0 to 3, r is equal to 5. So r is equal to 5. Normal distributions, guys. So we have, of course, this is will be equal to 5. Then you have phi from okay, 30 to 60. Then the second one is from z, 0 to 3. Then it is equal to what? 5, 60, negative 30. Then you have 3, negative 0. So which equal to 5 multiplying by okay, 30 multiplying by 3. Okay, then you will get the answer, or you can put it like this, 5 pi divided by 2, also correct. It has been converted to 330 is what? Divide by 6, because 180 divided by 6 is equal to 30, and pi divided by 4, which is 180 divided by 3, which equal to 60. So both are correct. Okay, let's say this example. This example, find the expressions for the unit vectors of A, okay, as shown here in the cylindrical coordinates. So we can see this example geometry, okay, which we have 2 points. We have O to P1 and we have O to B2. So first we have to identify the triangle points. What are OP? So we have A vectors which equal to what? This one, OP2 negative OP1. So OB2 negative OB1. So the value here are negative this value. So that's why we have this is the vector of A. Which equal to what? RO negative 0, isn't it? Then we have phi O negative 0, and we have 0 negative H. Okay, so in this case, what we get? So we will get R vector. Sorry. R vector RO negative Z vector H. Okay, and this A is equal to what? This is the unit vector, which equal to A vector divided by the magnitude of A. Magnitude of A. So of course, A, if you want to find A, phi has been found here. Divide by the magnitude. Magnitude, we already know how to find it. Equal to root of R square positive H square. Okay, you can see it here is more clear. So we have OB2 equal to OB1 plus A, or you can see A vector is equal to OB2 negative OB1. So in this case, we have RO of the vector of R negative ZH of the vector of Z. Then this is, we have got the vector of A divided by the magnitude. Magnitude, we have to find it, isn't it? Which equal to root square plus H square. Okay, so this is for the cylindrical coordinates. Okay, then we have to move into the spherical coordinate look like this, okay, which we have the point of P, okay, then you have O. So what variables you have? You have phi, theta, r, and phi. These are the variable for the spherical. So we have to know the variable of these three coordinates. We have Cartesians, and we have cylindrical, and we have spherical. These three parts. We have already described the Cartesian coordinates, and we described the cylindrical coordinates, and now we move into the spherical coordinates. Spherical coordinate, as I see, their variable are r, theta, and phi. R are the distance, okay, from the original, which is this one, r, which is a distant. And phi or theta are what? Are the angle between z, okay, and the original line here, this one. Also, phi here is describing the angle between x and the project in z, this one, coming from z plane. Okay, so let's see what we have. So unit, as I said, are phi or theta phi, which describing its variables. And we have the differential length is dl is equal to r based on differentiate based on r based on theta and based on phi. But you have to add this one, r sine theta. Okay. As long as you know how to use the equations, okay, it is good enough. Then we have the differential surface, exactly same as I described it in cylindrical. So we have it for three parts, right? We have for the first variable of r, and we have variable of theta, and we have variable of phi. These are equal. So we have to identify each of these surface when we solve. So example, if the surface asks me to find this surface, the questions ask. So in this case, I have to use this one, r sine theta drt phi EO, which is the unit vector. And the differential volumes, okay, is also a fixed equations. We have r square sine, then you have differentiate derivative based on r, theta, and phi, which is here are the descriptions. This is for one above, you have it for the side, okay, and you have it for the bottom one. This is the volume. So we can see also the increasing of length is different from the differential increment, where we can see differentiate of derivative of r, which is in between the two radius, and also we can see differentiate or the derivative of theta multiplying by r, which is a distance between two angles. Also we can see the third part r sine derivative of phi, which is also the distance between two radial planes at angles. Okay, this is just repeating from the previous slides, which you can see the unit vectors. The vectors are A, okay, could be in these three directions, three variables. Then the magnitude also the same. You have A square and second E phi square and E theta square. And of course, if you want to find the position vector, which could be from E to B, you see this is the positions from O to B, right? Which you can see is R vectors R1. Okay, before you solve any example, you have to identify, or you have to know this example is what type of coordination. Okay, what kind of coordinates are Cartesians, cylindrical, or sphericals? So before you're solving any example, then you check what equations you want to use. Is it volume? Is it length? Or is it surface? We have only three. Let's say this example. We have sphere. Of course, when I say sphere, mean this is what? Spherical coordinates. Okay, fixed. It is spherical coordinates, while we have radius is equal to 2. So radius are equal to 2. So R is 2. Contains a volume charge density, BV. Okay, then of course, BV I have to be given 4 C per meter per 3. Find the total charge of Q contained in the sphere. Okay, so we have this example is a fix. Q is equal to phi V B volume dV. What are the volumes? The volumes, you go back, check, you have this equation. This equation is fixed. So this equations, just rewrite it. Okay, rewrite it. So I will just rewrite it, which equal to integrations for what? For R. Okay, R square I have to put this is 4 also. 4 R square sine theta d r d theta d phi. So I have 3 derivatives. So I need 3 integrations. I need 3 integrations. First integrations, second integrations, and third integrations. So the first integrations is okay, R here. So for example, this R what? We have it from here. So this integrations for R is from 0 to 2 centimeter. 2 centimeter are what? 2 centimeter is 2 multiplying by 10 into the power of a negative 2. Okay. The second one, which is phi. So phi is also, as I said, is from 0 to 2 pi. And the third, theta, okay, is from 0 to 180. Why 180? Which is the half of the spherical. So there are 3 integrations. Okay, this is the most important, which you have to know. One for R, 0 to 2 multiplying by 10 into the power of negative 2. Okay, the second one is which for phi from 0 to 2 pi, and for theta is from 0 to 180. Okay, you have to understand this. You have to get these points. If it is not giving to you the range of phi and theta, in this case you have to identify is equal to 0 to 180, and the second one is from 0 to 2 pi. If it is giving to you in the questions like here, then you have to identify. If this question doesn't have radius, in this case you put from 0 to what? To r here. You have to make it as a variable. Let's see how it is equal to. So we have already know how did I get these equations. So now what I have to do, I will need to do integrations. That's it, right? How to do integrations? I have to separate the variable. Based on r, I separate it here. Based on theta, I separate it. Based on phi, I separate it. Then I will do the integrations one by one. For example, I have r square will be r power 3 divided by 3 from 0 to 2 centimeter. Then from sine phi will be negative cosine phi from 0 to 108. Then I have 0 phi from 0 to 2 pi. Then I will solve. Can you tell me what is equal to? Can you calculate this? Let me know it's equal to what? Hello guys, are you around? Ahmed, Dara, Dulivan, Hamid, Merivan, Muhammad.
Yes, sir, we're here.
Okay, try to solve this one. This is what equal to what? Okay, try to solve this. Let me know what is the value of q here. Total q is equal to what value? Hello guys, are you doing now? Are you doing this example?
Yes, sir, yes.
Okay, good. Don't be silent, guys, please. I want to feel you are with me now.
Well, sir, I don't know. I got 0.
You got 0. Dara, how about the rest? So let's try together what we have. So we have 4 and 2 into the power of 10 into the power of negative 2. Negative, oh sorry, here negative 0. Negative power 3, negative 0. This is number 1.
No, sir, I got 0.33. I made a mistake.
0.33.
33, yeah.
Let's calculate it together. So I have a negative, okay, multiplying by negative cosine 180, okay. Very good. You know, I can see my writing is not good because I am using mouse. 2 by negative 0, okay. Then you have 2 pi. Can we just calculate this part? So we have 2 multiplying by 10 to the power of negative 2 power 3. Okay, you got multiplying by 4. So you have about 0 point 0 or 0 0 4 zeros, okay, 32. multiplying by cosine 180. Okay, cosine 180 is equal to -1. Okay, so this is equal to -1 multiplying by -1, +1. Okay, no problem. Okay, so we have +1 here. Multiplying by 2 pi, which equal to what? Let me say, so I will have 0.00.
I think it's +2. It's not +1. I mean, +2.
Yes, he's right because we've got another
Because
cosine, which is
it's
cosine zero.
cosine 0 as well. It equals to 1.
Cosine 180 is equal to -1. You know that?
Yes, multiplied by negative, it's 1. Plus another one because it's from cosine 0.
Oh, okay, very good. Okay, then we have negative.
+2.
Yes, positive cosine 0. Then you have 1 here, isn't it?
Yes, so it's 2.
So you have a +1 and +1, 2. Very good. Okay, so we have 0.00 multiplying by 2 pi. What did we get? 0.00042 and so on. Can you convert this to micro? You divide it by micro, then you get about 402 micro C. Okay. Is it clear, guys?
Yes, sir.
Okay, very good. Then we have the spherical strip is sections of a sphere of radiance. This is also another equations. So we have the radiance is 3 centimeter. Find the area of the strip. The area of the strip is equal to what? D S, which equal to R vector. Okay, which is here we don't have it, but we can is equal to 0. Then you have R square sine phi, okay, d phi. Okay, so we have two integrations parts. So if you want to have the surface, so surface is equal to two integrations, integrations 1, integrations 2. Okay, then you have for d phi and d theta, which we have from first one, as I say, from 0 to 2 pi. But theta here are theta. Okay, theta are here, which we have 30 and 60. You can see here are theta and here are phi. Phi as all this circle. Okay, it didn't identify here. That's why it's from 0 to 2 pi. From 0 to 2 pi. Then we have the second one, which is theta, which is from 30 to 60. Then we have r square sine theta, then d theta d phi. Okay, then is equal to what? R square here is, you have 3 here, r radians. So 3 multiplying by 3 is equal to 9. Then you have integration, first one, 30 to 60. Okay, for the variable of theta, you have sine, so you have sine theta. Okay, Then you have the second one, integrations from 0 to 2 pi 4d phi. Okay. Since you identify these two, you just need to do the integrations part. To do the first integrations, as I said, is you have to convert it. Sine will be negative cosine. Then you have d phi will be 2 pi divided by 0. So if you convert this part, so you will have 9 negative cosine 60. Then you have negative, and this negative become positive, cosine 30. Then multiplying by 2 by negative 0. Okay, cosine 60 positive cosine 30, or you can see opposite, cosine 30 negative cosine 60, both are the same. So 2 pi multiplying by 9 become 18 pi. Then cosine 60, let me say cosine 60 is equal to what, guys? 0.5. So here we have negative 0.5. Okay, then positive cosine 30 equal to what? 0.866 something, okay? Which equal to, so negative 0.5 multiplying by 18 by which equal to 20.69. 8 centimeter per negative 1. Okay, this centimeters comes from here. Okay, from this one. Okay, if you want to have multiplying by 10 into the power of negative 2 is also possible, but if you didn't multiply, then at the end you have to put centimeter. Clear? I wish, guys, I wish if you, I mean, once we solve practice, I wish that all of you have pen and paper so that we could practice together. Okay, guys, please don't watch me like watching any movie. Please, you have to contribute. Okay, second one. We have this one. We have sphere of radius is 2 centimeter. Okay, and contain a volume charge is density BV, which is giving to us. BV is equal to 4 cosine 2 phi. How to solve this one? How to solve this example? Okay, so Ahmed, how to solve this one?
Who's Ahmed, sir?
Anyone, any Ahmed? Who knows how to do this? This is exactly the same as this one. Exactly. Okay, exactly the same. You use the same equations here, okay? But what we have here, instead you have 1 here, you have 4. So where is the here? Okay, exactly the same as this one. So you have here instead of 4, what here we have? We have 4 cosine square. So you change this 4 to 4 cosine square theta. So let's say what we have here. So we have integrations, 3 integrations. Then we have 4 cosine square phi. Then we have r square sine phi dr d theta and d phi. Okay, so we have to describe this one. So you have to you have it from r is from 0 to 2 centimeter. Then you have it from 0 to 2 pi, 0 to 2 pi. Then you have from 0 to 180. Then you do the integrations. If you do this, you have this integrations. I think this integrations with this integration, sine and cosine. Okay, sine and cosine, I believe you know, 2 multiplications. Or you can see cosine integrations of cosine square, and you have here sine. How to do this? We already know that this cosine will be like this. Cosine square phi will be 2. Okay, will be cosine to sine phi. Okay, you have to do this integration part one by one. At the end, you will get 44.68. Okay, you can do it at home, isn't it? Can you do it now? Let me. But this is a quite long equations. Okay, not very long, but it is tough for me to write it. If I have a tablet, that will make it much easy for me to write it for you guys. So please try to solve this one at home. Okay, and I will also solve it together, then we compare our answer. You exactly use the same, and I want you to compare your answer. Is it equal to 44.68 or not? Okay. Is it okay to all of you guys? Hello? Hello, my
Yes, sir.
friends?
Yes, we are with
Hello,
you.
sir.
Are you here, guys, with me? Are you alive?
Yes, sir.
Yes, you are alive, sir.
Okay, good. This is table will help you when you answer any example. Okay. First one, we have the coordinates variables. First coordinates, Cartesians. Second coordinate, we have cylindrical. The third coordinates, we have spherical. This table has all the equations that it is necessary for you to use it. Okay, very easy. I think if I am not mistaken, this table will be attached to your exam, so you can refer to this table. Okay, you need to understand. You are not required to memorize. This table I will provide it to you. Just most of my previous students, they know how to do that, they know how to answer, but they don't know how to do integration. Okay, guys, please try to practice. By practice, you will get a high mark, or the percentage of getting mistake is low.
Sir,
And you have, yes.
all the subject is based on this one till the end.
No,
Or
no,
it
no,
will
only
change?
this chapter.
Okay.
Because if you don't understand this chapters, we cannot describe some field of electromagnetic. Then I will reverse back to this chapter again. So I prefer to finish this chapter, then I move into more details.
Okay, sir. Great.
Yeah, I think we have to fill in. There is a lot of slide here. I provide many slides for you just to understand, okay, to gain more knowledge, okay, especially in these vectors. You need it in many subjects, electromagnetic, you need it in wave propagations and antenna, and you may need it in microwave engineering, microwave device. I think you have microwave device subject, yes? You need this topic, vectors analyze. You will use all. So once you have in some other subject in future, you can refer to my note as well. And this is the vectors, as I said, based on these three coordinations. Then we have magnitude A for 3. Then we have a positions vector for the 3 coordinates. Then we have vector properties for the 3, dot product for 3, cross product for these 3, okay, also length for 3, surface area for the 3 coordinates, and we have the volumes for the 3 coordinates. So from previous classes, all are including in this table. Okay, so this table is very important for you. You have to cover it all. Okay, what we have here, coordinate transforms. Coordinate transforms mean, so we want to transform from one coordinate to another coordinate, isn't it? So that is the meaning, which is here to solve some system, okay, which is also fit into the geometry. So for example, we can see here the Cartesian coordinate, which is based on x, y, and x, okay. And this time, if we want to transfer it in between the Cartesian, so you will have r equal to root x squared plus y squared, while you have phi is equal to tan into the power of negative, okay, inverse y divided by x, okay. So of course, and if you want to transfer it, x will be r cosine phi, then y is equal to r sine phi as well. So these the transmissions between the coordinated system. Okay, at the end of this transmissions, I will have also another table to describe to you to make it easy that all the transformations equations are in one tables, so you don't confuse. Okay, let's see what we have. Coordinates transmissions unit vectors. Okay, so we have here piece, as I said, in x and y. So in this time we have r dot x is equal to cosine, and phi dot x is equal to negative sine phi, which equal to cosine pi divided by 2 plus phi, and z dot x, which equal to 0. This is just a general transmissions in unit vectors. So let's say also the relationship between two coordinates. The first coordinate are Cartesians, and the second one which cylindrical. How did I know this Cartesians? I see this is a Cartesian coordinates because I have variable of x, variable of y, and variable of z. So this is Cartesians. And the second variable is what? R, phi, and z. So these variable R represents the cylindrical coordinates. So in this case, we want to transfer from Cartesian to cylindrical. How to transfer? So we have to use these 4 equations. We have to use these 4 equations because the question will ask giving me Cartesian, and the output we need to have to transfer it to the cylindrical. So we will use this equation 1r. So I will change all x and y to r, and I will change all x and y into phi as well, okay. And here also I want to change all r and phi into x, and I want to change all r and phi also to y. These equations when we in between the Cartesians and the cylindrical. Then we have the Cartesian to spherical transfer, which we can see this is x, y, z, and spherical, which we have r, theta, and phi, are showing in this figures. So we have to use also about 6 to 7 equations, right? Which we have r, phi, theta, and phi. Why do we need this? To convert all x, y, z to r. To convert r, y, z to theta. To convert x, y, and here are 0 to phi. Also here the same, different from spherical to Cartesian. Also we convert r, phi, and theta to x, and so on, to y and to z. The table are showing to you all these transformations, okay? Transformations we have from Cartesians to cylindrical, okay? Cylindricals, what we have. So for coordinates variables, we have r, we have phi, and we have z here, isn't it? And we have unit vectors, and you have vector components. These are very important, so we have to check if the questions is asking me to say to convert from Cartesians to cylindrical, then in this case I will use this column, this row, okay? If from cylindrical to Cartesians, we have to use this one. If from Cartesian to spherical, we have to use this, and so on. Okay, so let's have an example. Before we end English sessions, let's just see one example. Let's see this example. What is this example? Example is express the vectors. We have x, y, z. When you see x, y, z, you identify this is what? Cartesian coordinates. This is Cartesian coordinate. So what we need to have? We need to convert it to spherical coordinates. So if we want to convert it to spherical, so we use, so from Cartesian to spherical, Cartesian to spherical here. So we have to use this part. So we have to use this part, which is A R E phi or theta and E phi. These three one by one. Let's write it back. So I will just write this one, first one. Okay, we write this one. Okay. From where did I get this? From the table, from here. This one, I just copy this and put it there only. Once you copy this, then you have to identify AX. AX is this one. AX, X plus Y. So you write X plus Y. EY is this. And EZ is here. So EY is Y negative Y. So Y negative X, sorry. Then you write this back, sine. Then EZ, you have Z cosine theta, okay? So you put Z here. The first step, is it clear, guys? What we need to do, I will copy the equations from the vector component 1, then I will change EX, EY, and EZ from the vector, okay, from the Cartesian vector. So once I do it one by one, so what I need, I will need X is equal to, so what I have here, so I will have X is equal to okay, we have where is it? Cartesians. Yes, we have this one. 1, 2, and 3. Why we need this? I want to change all X to R and theta and phi. I want to change all Y to R, theta, and phi. I want to change all z to r and theta, isn't it? So because I have x and y, you can see this is mix. This is Cartesian and this is spherical. This is Cartesian, this is spherical. I want to convert this all to spherical. So I use this one. X, you have to be careful, Cartesian to spherical and this part. Spherical to Cartesian. So I will use this part. So x, I change all x to r sine theta cosine phi, all y to r sine phi sine theta, and I will change all z to what? To r cosine phi. Let's do it together. This one r, so r, we have r. Try to write it faster, so we don't have some time. So we have sine, okay, cosine phi plus r sine theta sine phi. Okay, then you have sine multiplying to sine phi cosine phi. Okay, all this. Oh, it's too long. Okay, here we don't have space, so you continue y negative y, so you write y, which equal to negative positive r sine theta sine phi, and negative x, which we have r sine phi cosine theta. Okay, then you have a positive z, we have r cosine, so r cosine phi multiplying by cosine theta. Once you do all this part, so you will get r sine square and cosine square, and this is will be equal to r out sine square positive cosine square is equal to 1, so at the end is equal to r. So the first IR is convert to R. It's convert to R. The second one, which we have to write it from here, second one here. So you redo the second one, E phi. You copy E phi or theta here. Then you change one by one X, Y, and Z. Okay. Then you change using this one again, and it will equal to 0. Then you do the third one by E phi, which is this the last one. So when you do the last one also, you have X, you have Y, and here again you have Y and X. So once you do it, you will get negative R sine phi. So we change it to the spherical is what? We will have this R vectors, phi vectors, and theta. Number one, we have ER. ER is what? ER is already giving to us, which is R. So we put R. Then E phi is 0, so we don't need to write it 0. Positive phi, negative sine. So you write negative R sine theta. Okay, did you get the concept, guys? Hello?
Yes, sir.
So at home, please, guys, you need to do it one by one, okay? So you have to check these equations, take it, put it here, okay? then change all x, y, z to r, theta, and phi, and you can get the transformations. This is a very important question. You may have it in one of the exam. Okay, you try to do also the second part also the same, then we can continue, I think, next online class. Okay, I have to move on. So next online class, I think I try to cover most of the topics. Okay, so because I have to be quick in maths, then we go into more details. Okay, do you have a questions before I end the session? Do you have any questions before I end the sessions?
No, sir.
No,
Okay,
sir.
good. How about the rest?
No, sir.
No questions, sir.
Okay, thank